resume recording. Welcome to those that are viewing the recording. I hit the record button a little bit late, but we're just about to get started. I will send out these recordings sometime early next week. And if you can't stick around to get all the questions answered, you can always view the recording and we'll answer those there. All right, so jumping right in. As I said, we're going to be talking about red alder today. Red alder is one of my favorite Western Washington species. I think it has a lot of potential for a number of different reasons. So getting into the basics here, let's just kind of start at the basics. The scientific name of red alder is Alnus rubra, which literally means red alder. It is in the Betulaceae family, which is actually the birch family. So it's a cousin of the birch, and maybe that's related to why its bark is also white. And some people often confuse red alder for birch. In terms of height, it typically grows to 40 to 80 feet tall, although the tallest is 105 feet on record. And in diameter in mature trees is around 22 to 30 inches, the largest being 78, which if you do the math, that's over 6 foot in diameter. That's pretty large. And I think that's somewhere in Oregon. The crown is typically between 35 and 50 feet, although in dense stands, the crown can be quite narrow. And in terms of age, it's actually a relatively young tree. I like to call it the live fast, die young tree. Typically lives to around 60 to 70 years, maxing out at about 100. So sort of the lifespan of a human. In some notable features here that we'll dig into in the subsequent slides, it is a nitrogen fixer. It has rapid juvenile growth, one of the fastest juvenile growth rates of any Washington tree. It's shade intolerant and considered a pioneer species. We'll talk about what that means. And it is one of the largest Alnus species in the world. Where I come from in Michigan, alder is just a shrub. And I remember moving out here, doing a little bit of research, learning about red alder as a viable timber species. And it kind of blew my mind because I didn't know that alder could be more than a shrub. But here they have very large red alder trees. And it can be, and it often is, considered a weed, especially in the context of timber management and especially on industrial lands, because they can outcompete some of our more valuable coniferous timber producing species. So in terms of identification, I'm sure many of you know how to identify red alder. It's just so commonly occurring, but we'll dig into this really briefly. Oval shaped pointed leaves that are coarsely toothed. You can see the margins here are coarsely toothed, and they're sometimes curled underneath. You can see that margin is just a little bit rolled under. So that's a good way to identify it. The veins underneath can tend to be a little bit hairy, and the leaves stay green pretty much through the fall, especially this year. They were green well into November. And they don't really turn a very bright, vibrant color in the fall either. They just kind of turn brown and fall off. The leaves are arranged alternate. That's an important identifier. So you can see over here, the leaves are alternating on either side of the stem as opposed to being opposite like big leaf maple, which we'll talk about tomorrow. And it's a good way to winter ID red alders by looking for that alternate bud arrangement. The bark is brownish green when young. You can see it here. And then it turns gray-white as it gets older. And it has a red inner bark, which is where it gets its name from. So just to step back for a second, the male flowers are long catkins, which you can see here. And then the female flowers are these short woody cones. And in terms of range, it has a really long one. It grows all the way up into southern Alaska, even all the way down to sort of central California. And it has different, preferred sites along this gradient here. In Washington, it's anywhere where there's moist soils with adequate drainage, floodplains, stream banks, drainage slopes, and usually below 1,500 feet in elevation. So I want to dig into its life cycle briefly here. It reaches sexual maturity by age 5 or 6, so it's producing seed relatively young. It's monoecious, which means that it has separate male and female parts, but they're on the same tree. So it has the male catkins here, and then these female flowers here. So they're hosted on the same tree, which means they can actually self-pollinate, although they're usually cross-pollinated. The flower in late winter and early spring. So here's the flower in April into June, July, August, where it eventually turns into that woody cone. And it's a very prolific seed producer. The seeds are these small winged nuts, typically disseminated by winds because they're very light. They can also be disseminated by water and even birds, but very, very light and often spread by wind. So these are the seeds here that I mentioned, very light winged nuts. So the seed establishes best on moist mineral soil. This goes back to what we talked about with red alder being a pioneer species. It likes sites that have been disturbed. Historically, it might have been a fire. In modern times, it might be a harvest, something that exposes that bare mineral soil that the seed likes to get established on. And the seeds are very small. So you have to keep that in mind. They have less food reserves, less time to find root substrate. Really, there isn't a very long dormancy period for red alder. If it doesn't get established in the first year, it's not very likely that the seed is going to germinate in the next year. It just happens to produce so much seed each year that it's not really a problem that it doesn't have a very long dormancy. The survival and growth rate is typically excellent, as many people will attest to that have natural red alder stands. If you've got a really good red alder site, you're likely to get a lot of volunteers. And that rapid juvenile growth. So height growth can exceed 9 feet in a year. That's sort of the top, pretty exceptional. But it often reaches half of its height potential by age 15. So again, that sort of live fast, die young mentality. It is very, very fast growing in its early years. And it can also produce vegetatively, which we would call stump sprouting. So if you cut it and then it'll resprout from stumps, sort of like big leaf maple does. Big leaf maple is very popular in that sense. But because of that, it could be managed via coppicing. It could also potentially be pollarded, if anyone's familiar with that process. So moving on, after establishment, growth really slows after age 20. But it does continue to maintain relative vigor for another 10 to 20 years before it starts to get towards a decline. And it can create really dense stands, which is good because it's effective for self-pruning. Red alder is a very good self-pruner, and it requires relatively high density in order to initiate that self-pruning. So the trees reach maturity by age 60 to 70, maybe 50 earlier than that, and then they begin to decline. So they really at that point start to tip, and you get what's called a decadent alder stand. And these are really common in Western Washington, largely because of the last 100 or so years of harvesting, and not so much recently, but post-harvest burning really made good site conditions for red alder to get established. And then they, continue to grow. And what a lot of landowners are working with now is 50, 60, 70-year-old decadent alder stands. We'll talk about that a little bit later. So it produces a very light shade, which can actually be a problem. It can allow noxious weeds to develop in the understory. I have been in red alder stands almost as dense as this one we're looking at that actually just overrun with blackberry in the understory. And blackberry, as we know, is a very shade intolerant noxious weed, but it was able to get established underneath that because red alder tends to let a lot of light in on the ground. This also creates forage opportunities for anyone interested in doing something like silvopasture, which I'll talk about a little bit later. So in terms of damage and disease agents, despite this long list, red alder is relatively free of disease and insect damage, at least stuff that's going to be ecologically or economically concerning at a stand level. But there's a few here, and I'll kind of go through them quickly. As trees get older, this heart rot becomes very common, the Phelinus igniarius. It's very common in 50, 60, 70-year-old trees. That's where you get that top break starting to occur a lot. It's also susceptible to armillaria and anosis root rot, which I was not aware that it was susceptible to anosis root rot until I was doing a little bit of research before this. So armillaria, for those that aren't familiar, is a very wide host range. There's really nothing that's really immune to armillaria root rot. But it tends to often be a secondary pest taking down trees that are already stressed by other things. Anosis root rot can sometimes be a little more aggressive, but it tends to be on, conifers, particularly our true firs like grand fir and then some hemlocks as well in Western Washington, at least. So it was really interesting to learn that red alder can actually be affected by anosis, because I didn't think hardwoods were susceptible. So interesting finding there. When the trees are young, they can be affected by some cankers, but not necessarily at scale. Often it's, branch dieback and small scale damage. There is a whole suite of defoliators that might affect red alder. These are two of them. Forest tent caterpillar, many people are familiar with. The alder flea beetle is something that we had to deal with like 2 or 3 years ago. There was a big population boom in the alder flea beetle, and we got a lot of skeletonization of the alder foliage. A lot of people were really concerned about that, but these defoliators tend to follow boom and bust populations where, every few years, 5-7 years, I've heard, their populations will boom, and then of course their predator populations will kick in and sort of break that population. And so these cycles, and they typically don't do enough damage to really harm the tree. Red alder also has its own bark beetle, but it's a secondary pest, taking down trees that are already stressed by other things. It's not really a primary pest you need to worry about. And then there's something called the banded alder borer, which is over here. And this is a detrivore. It likes dead wood, so it's really not anything to be concerned about. But I wanted to note that it is often can be confused for the Asian longhorn beetle, which is an invasive beetle that we're on the watch for in Washington. And I didn't have the forethought to put up a picture of the Asian longhorn beetle, but this is the banded alder borer. And it is not the Asian longhorn beetle. It's nothing to worry about, native, and it's just doing the good work of turning those downed red alder logs into soil. In terms of, skipped right through. In terms of climatic factors, wind break. Older alder trees tend to be susceptible to wind break. Again, a lot of it because of that heart rot, but they're pretty wind firm. They don't often are not very susceptible to wind throw. They develop very fibrous root systems, unless they're in sort of wetland areas where their roots are limited, not very susceptible to wind throw, but wind break at the top in older trees is common. Frost pockets can be very damaging to seedlings. So if you're planting red alder, that's important to know. And it is very susceptible to fire, although fire is not terribly common on red alder stands. That tends to be wetter sites, and in Western Washington we have relatively infrequent fire ecology. Sorry. In terms of animals, they're susceptible to all kinds of animal damage. Deer and elk browse is for sure an issue, although it is not the preferred browse. And then there's things like beavers will use it for their lodges and stuff like that, but not a terrible amount of damage from animals to red alder. All right, digging into its sort of ecological role and importance, red alder can grow in pure or mixed stands. It has a very wide range of sites that it can grow on, so it's going to grow with a lot of other stuff. It's a long list of associated species here that I won't dig into. But as we said, it's a pioneer early seral species. It moves in after there's been a large disturbance. Often we'll say it needs an acre or more gap in order to really get established. But it can definitely get established in smaller gaps. But if we're managing for it, you typically want at least an acre gap in size in order to replant something like red alder. And it's a very important riparian species. Reduces soil and stream bank erosion. It loves to grow along those stream sides, and it enhances riparian habitats by providing shade, woody debris, and nutrient inputs through its foliage. In terms of importance to wildlife, as we mentioned, deer and elk will browse on the twigs and foliage, and beavers will also use the fiber for their dams and lodges. Small birds like to eat the seeds, plus, of course, there's nesting habitat. And then mice and small mammals will also feed on the seed. One of the key things about red alder, though, in terms of its ecological importance, is this nitrogen fixation. It's it's our only nitrogen fixing tree that I'm aware of. And so it plays a really important role in sort of the nutrient management of a forest. So for those that aren't familiar, nitrogen fixation works through a symbiotic relationship with nitrogen fixing bacteria, Frankia, housed in the nodules of certain species. And red alder is one of these. So it has that relationships, and these nodules, you can see them over here. So basically the bacteria is taking atmospheric nitrogen, N2 gas, out of the air and turning it into plant usable forms like ammonium and nitrate. And in exchange, the tree gives the bacteria carbon and sugars. So it becomes this very mutually beneficial relationship. The good part is that nitrogen that gets added to the red alder eventually ends up in forest soils, either through leaf litter or decay of biomass when the tree dies, root exudates simply seeping out of these roots, and mycorrhizal associations. So these red alders are sort of a source of nitrogen, a way to kind of tap into atmospheric nitrogen and inject a bunch of it into that system. They're very good for building organic matter and nutrients on poor sites. This is a picture that I took just a couple of days ago. All the alder foliage on the ground. This was bare soil. This was a trail that I built, actually. And this was bare soil even a month or two ago. And you can see just how quickly the organic matter can build up after a few years of this leaf litter. Some other things that I found doing a little bit of research on the cool features of red alder. It is proven to increase soil fertility, microbial biomass, and microbial activity. It can accelerate rock weathering of other nutrients like phosphorus and calcium, which come out of rocks as opposed to nitrogen, which generally comes from the air and the atmosphere. This is really important because nitrogen fixation is a very phosphorus intense process. It requires a lot of phosphorus to do. So the fact that they can accelerate rock weathering and add phosphorus to the soil as well is really important. The young growth alder sites have actually been linked to increases in macroinvertebrate export downstream. So in the headwaters, they can increase macroinvertebrate populations, which is obviously important for fish habitat. And in its whole range, is host to over 160 lichen species on its bark. One tree is probably not going to host 160 lichen species, but from California up to Alaska, it hosts a wide range of lichens. In terms of past uses by indigenous peoples, red alder had a wide variety of uses. The dye from the inner bark, where red alder gets its name as that red inner bark, that can be used for a dye. The bark and inner bark were also used to treat headaches, coughs, wounds, and joint aches. Wood was used for a number of things, I'm sure, but some examples were dishes and utensils and ceremonial pieces like masks. And the young stems could be used in baskets or lashing for sweat houses. Wood is, of course, used to smoke salmon, something we still do today. And there was actually some evidence of sap collection used to treat wounds, in fact. So this is really interesting. Tomorrow we'll talk about big leaf maple, which can produce a very sweet sap. Very little evidence of sap collection here from big leaf maple, but interesting that there was sap collection from red alder. And of course, this can be an important source of fuel wood, and of course still is today. In terms of modern sort of timber products, alder is a really great species. It's a moderate weight and hardness. It's very workable. It's very easy to machine. It sands well, and it accepts a wide variety of stains. So you can make it look like just about anything, which is why it makes a great veneer. The peeler logs can be very high value, but it's also used for plywood, furniture, cabinetry, musical instruments, chip and pulp wood, of course, pallets, things like that. The market can be very volatile. We could do a whole class on this, I'm sure. But it can produce a very high price per board foot. And I just looked at the Washington DNR does a survey every month to get board foot prices. And in October, it was $750. That's where it was topping out, which is pretty high. And I should have compared it to Doug fir. If someone knows what it is for Doug fir right now, they can plug it in the chat box. But sometimes red alder can actually exceed the price of Doug fir, which is really interesting. But the thing is, there's a difference between knotty alder and clear alder, and management is really critical in that. And most small forest owners probably have knotty alder, which came out of a unmanaged stand, which is usually less valuable. So I want to talk about some agroforestry opportunities, because I think red alder has a lot of potential in this sense. I mentioned forage opportunities because it produces such a light shade. It's a great opportunity for forage production underneath, and you can kind of see that here. It also produces a tree fodder, and of course, it's a nitrogen fixer. The small diameter stems can be used to grow log-grown shiitake. This is a part of a research project I'm involved with some other extension agents. And because it uses that small diameter wood, it's very conducive to early thinning. A good excuse to go out there and thin out some of your small diameter stems, keep your stand vigorously growing, and get some shiitake mushrooms out of it. And again, because of that light shade, it creates opportunities to grow other forest crops. I threw a couple examples in here as well. So I want to talk about management. I'm running a little long, so I'm going to try to speed up here. In terms of site selection, this is important. We like to think that alder is going to grow just about anywhere, and that's because it's true. We will see it establish just about anywhere. But that doesn't mean it likes to grow there, and it doesn't mean it's going to grow very well there. So it really likes moist, well-drained sites. It is true that it's a tree that loves a lot of water, but it doesn't necessarily like to have its feet wet and have its feet soaked. It's like those sites that are going to be well drained, but still plenty of moisture. So your loams and your sandy loams are really good sites. Salmonberry is a very strong indicator of a high quality site for red alder. And if you're thinking of planting red alder and you're really not sure how good your site is, you don't know if red alder was there before or anything like that, this is a really good publication. If you just Google this, you can find a copy for free by Connie Harrington on evaluating site quality for red alder. So in terms of site prep, an initial treatment is usually pretty sufficient, usually because that vigorous early growth puts that leader above competing vegetation and often puts it above browse height as well relatively quickly. So relatively easy species to plant in that sense. You can, of course, plant it by seed. This used to be done more commonly. It's not very common anymore, but more site prep is required. Seedlings are more common form of planting red alder these days. And of course, you're going to get volunteers on the right site. Anybody can attest to that has a really good alder site. You might go out and plant 400 trees and you'll end up with 900 because of all the volunteers. Again, avoiding those frost pockets is important when you're thinking about planting. And recommended density is between 9 and 12 foot spacing. Denser tends to be a little bit better because it forces that vertical height growth and it forces self pruning. So I wouldn't really go any wider than 12 feet. And now it is also possible, it's something people have thought about for a long time, of planting mixed stands, mixed conifer red alder stands for those nitrogen fixation benefits. And a couple strategies include sort of delaying the planting of red alder, planting your conifers first and then coming back later and planting red alder so that the red alder doesn't overtop the conifers. Another strategy would be just to leave small gaps and manage your red alder in small gaps inside of your conifer plantation. So you're incorporating alder that way. But you have to compensate for the fact that red alder is going to grow really fast, really quickly, and it can shade out your conifers, especially like Doug fir. So as I said, the high density encourages self-pruning and clean wood, but then hitting your thinning windows is really important. And anybody that's taken our coach planting class knows what that thinning window is. It's just getting in there while the tree is still vigorously growing and managing the stand density so they have the appropriate light, water, resources, and space to continue to grow vigorously. So your thinning windows are earlier in red alder, and red alder is much less forgiving compared to some of your conifers. So typically, it's going to flex based on site and other conditions, but you're going in around 5 to 10 years old, pre-commercially thinning, going from, let's say, 800 stems if you've got really a bunch of volunteers and going down to 400 or 300 stems, and then doing another thinning shortly after that, probably likely pre-commercial thinning too, and thinning down to 150 to 200 stems. And that's just kind of throwing some numbers out there. But the point here is you're maintaining a live crown ratio of about 50% in order to continue that vigorous growth. Whereas Doug fir could get down to 40%, maybe even a little less. Red alder really needs its crown to continue to grow vigorously. So that thinning is very, very important. When you don't thin, you often get that unmanaged stand. You're going to get knottier wood. It's not going to grow as well. And it doesn't produce as high value timber products if that's what's important to you. So if well managed, high quality sites, a regeneration harvest with saw log production could occur in theory as early as 30 to 35 years. And I know the DNR is doing some interesting research in this regard, especially here in Southwest Washington. And unmanaged stands, it's more likely a final harvest would be around 45 or 50 years. And then I got some numbers on maximum value per acre. here. Obviously, you know, it can produce quite a bit. It doesn't produce as much as Doug fir, but pretty significant numbers. And it's typically regenerated via clear cut, again, because it's shade intolerant, needs lots of light to regrow. There's also potential for a seed tree system, which is leaving 20 to 30 trees per acre to serve as a seed source to grow red alder. I'm not sure that this has been done, but red alder can get established under some shade, so that seed tree system is possible as well. There's also possibility for a shelter wood system in trying to grow conifers underneath red alder. And this is something that we could talk about on the next slides. We get into decadent stands and how we can sort of manage those for the future and in light of red alder basically decaying at 70 years old. One thing though, if you're harvesting, cut logs don't last. You don't want to just lay them down and let them sit before you take them to the mill. You want to take them to the mill quickly, because they're very susceptible to stain rots and decay rots, and they won't be worth much at that point. So I mentioned this several times now, declining red alder stands, and many forest owners are dealing with this. This is actually a declining red alder stand on a property that I managed for WSU. It is 60 plus years old, and I'm, you know, every time there's a windstorm, I see a new broken top or a completely downed tree, to the point where the canopy is well, it's just not a fully stocked stand anymore. We're looking at maybe in their 60 to 70% canopy cover, and it's leaving a lot of light on the ground for blackberry to grow. And the long-term trajectory of a stand like this basically is blackberry. So it's really important to be able to identify these stands and think about manage for the long term, especially when you're dealing with noxious weed pressure. So these common symptoms include large branches breaking, top snap, wind throw. Again, these trees are old, they're just more susceptible to pests and pathogens like heart rot. So underplanting, as I mentioned, underplanting of conifers combined with overstory thinning and harvesting is similar to what a shelter wood system is, where you're leaving some shade in the overstory and planting trees in the understory. Is maybe a way to sort of remodel these stands or restore their trajectory. And this is a really good publication. I won't dig into this in too much detail because my colleague Kevin Zobrist has here. So you can download this, get this for free on the WCU Extension publication page. So if you're in this situation, I really encourage you to read this. You know, historically, a declining red alder stand would have decayed maybe into or may have had more understory recruitment of western red cedar or other hemlock or other shade tolerance, or it may have decayed into sort of a shrubby ecosystem of native shrubs. But again, nowadays with our noxious weed pressure, many people are facing a long-term blackberry patch, which is just not what we want. So these stands require a little bit of restoration. Okay, so that is that. As I said, I knew I was going to go long. That was a full half hour. But if you all can stick around, I am happy to answer the questions in the chat. All right, go to the top here. Okay, so we got the first one way back when I started. I saw it about Phytophthora. So this person is seeing a lot of alder dieback of mixed ages at their place in South Whidbey. Is Phytophthora a possible culprit? How can Phytophthora be tested for if I want to test for my trees? You know, I'm not really familiar with anyone that's going to be offering testing services in that sense. But what you could do, and I really encourage you to do, is look into the DNR service forestry program, because you can get a forester out to your property and they can tell you what you're most likely dealing with. I really couldn't tell you without, especially not even without seeing pictures or anything like that, what you're dealing with. So I won't even venture a guess. But I would point you towards the DNR service forestry program. I'm sure they can get someone out to you to take a closer look. And if they can't figure it out for whatever reason, they can often bring someone from the DNR Forest Health Department, or their forest health, one of their forest health specialists can come and take a look as well. All right, scrolling down. Oh, it looks like, okay, great. Thanks. Looks like, Richard, you provide some more information on Phytophthora. All right. Steve asked, will we discuss the state of the marketplace and prices in mills currently buying? Steve, that's a really good question and beyond maybe the scope of what I can cover in this. But as I did mention, the market is extremely volatile and it's hard to talk about because of that. I know pre-COVID, well, I shouldn't even say that. Some of the trade tariffs that were put in place just before COVID, red alder market was really strong. And then it got hit by the trade tariffs, and then it got hit by COVID. And I know, in fact, from what I understand, some mills actually did shut down some hardwood mills. And I can't personally give you a list of hardwood mills, but I think it does exist out there. So I will try to provide that maybe in my follow-up email. Let me make a note of that real quick. All right. Let's see. Someone asked if I wanted to gather seeds, what would be the best time and method for doing so? Yeah. So this is really interesting. It could be kind of difficult because what I understand is those red alder cones, they tend to release their seed when they dry out. So it's gonna be sometime between basically now and the spring. When you get like a nice sunny day that might dry them out a little bit, enough for those cones to sort of expand or really contract actually, and allow that seed to fall out. So frankly, it's not the best answer to your question, but it could be just about any time between now and April when they start flowering again. All right, Phyllis says, for good research on the connection between alder nitrogen and salmon, look up publications of the Keshemuck Bay Research Reserve and Homer, Alaska. Great tip. Thanks, Phil. I hope I said Keshemuck correctly. I saw this comment when I was going through it, and Devin, you are absolutely right. Indigenous people not only used to use red alder, but still to this day use red alder for many, many things. So it's a good catch. So someone asked, so the sap can be harvested for syrup. Do you know the sugar content? I do, actually. If you know me, I've been involved with the big leaf maple syrup sort of projects going on, researching that and doing outreach around that. Last year, I did collect some red alder sap, and boiled it down. It had a really low sugar content. I think it was something like 0.5 or 0.6. And that's percent by volume. So I didn't get a lot of syrup out of it. I think I only got about a spoonful from a very small amount of sap that I collected. And I have to say, it tasted kind of funny. And I want to do it again this year to make sure I did it right, because I think I let the sap sit too long and it may be fermented a little, and that would affect the flavor. Because what I tasted like kind of a strange sweet and sour sauce is the only way I could describe it. But I don't want to draw conclusions from that, because I think I let it sit out there a little too long. So let's see. Sago asks, when thinning, will the cut trees coppice or will the shade prevent them from resprouting? In a fully stocked stand, more than likely, yeah, the shade will prevent them from resprouting. And again, you're going to be taking out the smaller, weaker stems anyway, so they're less likely to have the ability to resprout. Can you put the link for that publication in the chat? I mentioned a couple publications. Maybe you can remind me which one, and I can try to before we all take off here. Let's see. Chris asks, also recoppicing, is there an ideal age for first coppicing? I've heard it needs to be young or it won't regrow. Yeah, you wouldn't want to do it when the tree's lost its vigor, right? So past 20 years old, I don't think would be ideal for coppicing. Again, and 20 is really that mark where it starts to lose its vigor. It's still growing relatively fast at that point, but not quite like it is in its early stages. So I would imagine letting it grow, establishing a root system, and then being able to coppice. This is an educated guess, just to be clear. Sometime between 8 and 15 years would probably be the ideal coppicing time. Oh, and thank you to whoever plugged in the Find Your Forester link. That is where you want to go to find your service forester. And anyone listening that owns forest land, I really encourage you to do that. It's always a good service to have a forester walk around with you and just kind of help you understand your forest a little bit better. Can you briefly go over the blackberry alder ecology or provide a reference? I don't have any sources that have, and as far as I know, I'm not sure anyone's really looked into that ecology necessarily from a research perspective. All I can say is that the amount of light that alder leaves on the ground is more than sufficient in certain, I guess I shouldn't say in all circumstances, but on certain sites, and I've seen it myself, it's the only reason I know this, is that blackberry can become established in the understory, and it can become quite thick. And knowing that blackberry is a shade intolerant species that's saying quite a bit for the amount of light that red alder is leaving on the ground. It is not the most common thing. I think more often you would probably deal with other noxious weeds in the understory. But I've even seen actually like Japanese knotweed along seed stream sides get established under red alder, which knotweed is supposed to be shade intolerant too, from what I understand. So sorry, I don't have any additional sources on that besides to say that, red alder is something where you're going to have to follow or monitor on an ongoing basis with that understory composition. Let's see. Allison says also WSU's ornamental plant pathology program studies Phytophthora species and their impacts on ornamental and native species. Yes, at the Puyallup Extension Center. Thank you, Allison. That's a really great link. So Angela says, several red alders on my property fell over last winter in storms. Some of it looks like roots pulled out of the ground rather than stem breaking. Is there any way to tell if more trees are likely to topple this way? That's really interesting. If they were pulled out of the ground, one thing you might want to look at is the amount of what we call fine roots, which is roots beyond like the initial root collar and clump with, large diameter roots. You might be dealing with a root rot. That's why I suggest that when you see a tree that's fallen off, that's been wind thrown, and there's really no fine roots on it at all, that is often because a root rot has actually sort of ate those roots and dissolved them away, and that's why it was no longer wind firm. That said, the one area where red alder is most likely to be susceptible to wind throw, even in a healthy state, would be on a very wet site where its root growth is limited. So if it is a site like that, and I have a site, in fact, the picture I showed you earlier was a site like that, it is possible that more of your trees are going to topple this way. It's also possible if you have a root rot. So I would recommend calling a forester, that service forester that I mentioned, and they might be able to tell if you're dealing with a root rot. There could be management options. If there's no root rot, I'd say it's probably not something you're going to have to worry about a lot, but it could be just a product of the site. And something to consider for future management, but not necessarily as alarming as a root rot. I'm not sure if anyone else has asked, but will a copy of the slides be made available? No one else has asked that, so that's a good question. I will make a note to make those available with the recordings next week. All right, lots of questions. Red alder is quite sensitive to drought. Given anticipated hotter, drier, longer growing seasons, attention to site selection will become more and more important. Sorry. If aiming to grow merchantable stands, may need to be careful about sites and now consider marginally dry. Absolutely. Thank you, Kevin. What we're seeing with these hotter, drier summers, this is exactly what Kevin described. Sort of the conditions that many of our native trees can grow on is narrowing basically to its more ideal sites. And honestly, if you're growing red alder for timber, you really want it to be an ideal site anyway. I will add, though, that red alder is one of the few tree species that I've seen very little drought damage. This is just my personal experience, and I'm kind of puzzling over that because red alder is not supposed to be very drought tolerant. But I've not seen very significant damage, at least compared to something like western red cedar or big leaf maple. All right, Steve says, down here in Portland area, I've seen many large areas of dieback in lower elevation areas. Climate change. That's so funny that you said that after I just said that I hadn't seen that. So, so that just goes to the nature of anecdotal evidence. It's very possible. Drought, the number one indicator of drought would be crown dieback. That tends to be how drought surfaces. And again, that's just the failure of water to get to the tree to get water to its extremities. So I'm not familiar with, or I haven't seen the trees that you're talking about. I can't say for sure. that's related to drought or climate change. Suffice to say that a large trend that we're seeing right now is certainly that these hotter, drier summers is leading to significant damage in several of our native tree species. And Western red cedar and big leaf maple are perhaps the most popular right now, but we're seeing them in all of them, really, including Doug fir. Let's see. Someone asked if the webinar will be available for viewing again. Absolutely. I'm going to send that all out next week. At the start of next week, I'll basically send out a website where you can get the links and the PowerPoint slides and anything else. All right, skipping through here. Randy mentioned a few hardwood mills in the Everett area. Yes, there is a mill in Centralia and Longview as well. Okay, I won't dig into that. I think I answered the last question, except somebody, you know what, somebody mentioned they cannot find the declining red alder publication. So I'll write a note to include that in the follow-up next week as well. All right. Oh, and Randy also mentioned, Randy, you must work for the DNR because you got some inside information. There's a site selection tool that's been in the works for a while, from what I understand, and I'm really excited to hear that it's going to come out at some point. The Washington Hardwood Commission, Randy says, is working with the DNR to make all their site selection tool available to the public. So far, it's only been for DNR uses. So that would be a very, very good tool for landowners to have. Let's see, we've got one more question here, and thanks V for posting that declining red alder link there. Steve says, I've seen a couple trees fall from root rot. How should I deal with it? If you are sure that they are root rot, which I just as a caveat, encourage you to have a service forester out to your site just to tell you what you're dealing with, because knowing which root rot is also really important, whether it's armillaria or anosis. But generally speaking, what we do with root rot, you have two options. You can do nothing, knowing that the root rot spreads relatively slowly and is a native pest and often just opens up gaps in the canopy, could create an opportunity to plant something different in that gap. Or you could manage it. You can go in there and basically cut out all of the affected area along with a 1 or 2 tree buffer width on the outside of that perimeter. So you're cutting out a big gap and basically stopping the spread of that root rot from root to root contact. And then you're coming back in and planting something that is immune to that. That's sort of the broad scope treatment of root rot, without getting into too many details. But as you can tell, because of that, it's very important to know which root rot you're dealing with so you know what to plant back. So I'm pawning so much off on those service foresters today, but I really encourage you to reach out to them, and they could help you with a more site-specific recommendation. But often, I will say most forest owners that I've worked with, aside from those that have really strong timber management objectives, with something like root rot, a natural pathogen, it's often okay to just do nothing and let that grow, and then treat it as an opportunity to come back and plant something different as those trees die. Especially if those trees are already old and they only have, another 10 or so years to live anyway. Does chipped alder make good mulch for gardens and lawns? I would say yes, absolutely. It's going to be a little bit higher in nitrogen content than some of the other materials or other trees. So it will decay probably a little faster for that reason, because it has a higher or a lower really carbon to nitrogen ratio. So it might decay a little faster, but it's going to have more nitrogen in it, which is good. That said, most of the nitrogen is actually in the foliage and branches of the tree, but still, and the roots. But if you're chipping the biomass of it, there will still be higher nitrogen contents. All right. Well, I feel like I've talked enough and taken 15 additional minutes of your time. So I will stop there and hopefully see you all tomorrow to talk about big leaf maple. Thanks, everybody.